Hello everyone, welcome to class once again. And in this class, we will be dealing with SS2 third week's topic, which is circle geometry, chord, arcs and angles. Now, of course, we know that geometry is broad, ranging from plain figures, which include circles also, to our solid shapes, and also angles sometimes. Okay, very quickly, we'll be dealing with this, and we'll be dealing with certain theorems on circles. Certain circle theorems. But before that, let's do a brief recap and discuss around what a circle is and the parts of a circle. Now, a circle can be defined as the locus of points equidistant from a fixed point. The locus of points equidistant from a fixed point. Now, take note. Let's assume this is the fixed point here, and the gap from here to here is 5 centimeters. Let's assume now, if you have another point here that has the same distance of 5 centimeters from here to here, and we have another point here that has the same distance of 5 centimeters, and another point here also, the same distance of 5 centimeters, another point here, same distance, another point, same distance, another point, same distance, just like that, and you create a chord line that can move through all these points like this. Just the way we do with our graph. The shape that is formed is actually a what? A circle. That's the shape that is formed. Okay. This here, the fixed point from which all other points are equidistant is known as the what? Center of your circle. And this curved direction, this curved line is known as your what? Circumference. So this is the circumference of a circle, what you know as the perimeter of your plane shapes. So if you have a square, this is the perimeter. This line creating the boundary is the perimeter of the square. But for your circle, it's not called perimeter, it's called circumference. Now, very quickly, this equal distance, or better put, any line that is drawn from the center of the circle and touches any point on the circumference is known as your what? Radius. I'm sure you know that, but like I said, we are revising. It's known as the radius of your circle, and any straight line that starts from one end of the circumference cuts through the radius and touches the other end of the circumference is known as what? Diameter. Now your diameter actually divides your circle into two equal parts, and a half circle is known as what? Semicircle. A half circle is known as your semicircle. Now, moving very quickly, let's talk a bit about this other part of a circle. Now you have your chord. What is your chord? Your chord is any straight line that touches any 2 points on your circumference. Like I said, this is your circumference, right? It touches any two parts of your circumference. Now the longest chord in your circle is actually your what? Your diameter. Your diameter, because this is the longest. If you check the distance between here and here, this actually seems to be the longest distance in the circle. If you pass it this way, it's still the same thing. Are you getting me now? So your diameter is actually the longest chord in a circle. Now, if your diameter divides your circle into 2 equal halves, like I said, 2 semicircles. But if you have your chord like this, it divides your circle into 2 segments. So you have your minor segment and your major what? Segment. Are you getting me? Yeah. Okay. Moving to the next one, you have our sector, and you have our arcs. Now, a sector is a part of a circle that is bounded by what? 2 radius subtended at an angle theta and an arc. Now, this is also a sector. Are you getting me? So we have 2 sectors here now. You can actually have more than 2 sectors in a particular circle. Just like when you draw your pie chart in your statistics now, you have your pie chart looking like this. You know, each value here, each one here is a what? Is a sector, right? Okay, so here you have your minor arc and your major arc. Now what is your arc? Your arc is a part of your circumference. It's a part of your circumference, and it's always looking like what? Like a curved line. But it is not a whole circle. It's always what? A part of your what? It's your circumference. It's not the whole circumference. And this sector now gives this one your minor arc, and this one has your what? Major arc. Why? Because this arc is quite bigger, and this one is what? Is smaller. Just like your segment here is smaller and is your minor segment, and the one here is what? Bigger as the major segment. Now the quarter part of a circle is known as what? A quadrant. A quadrant. We have learned the description of a circle. We have learned about the part of the circle and their meanings. So we'll be going straight into what? The theorems that involves chords, arcs, and angles. And the first theorem says that what? The angle at which an arc is subtended at the center of a circle is twice the angle with which it is subtended at on any other point on the circumference. Take note of what I'm saying. This is the arc here. Now the angle with which this arc is subtended at the center of the circle is A here, and this is an angle on which is subtended on another point on the circumference. Also take a look at the second angle here. A here is subtended. This is the arc here. Now this angle is subtended at the center, but it's also subtended on another point on the circumference. Now the principle or the theorem says that what? This A here, and A here, because this is the arc for this one also, subtended at the center, the angle that is formed at the center, or subtended, that is subtended at the center, is actually twice the value of any other angle subtended at any other point on the circumference. So A is equals to 2B in all three scenarios. Take note of the diagrams I do. A is equals to 2B in all scenarios. Okay, moving to the second theorem. The second theorem says that what? When a straight line is drawn from the center of a circle to bisect a chord. Now to bisect means to divide into two equal parts. So if it was drawn towards an end like this, towards somewhere like this, or towards somewhere like this, it is not bisecting. It only bisects. You only bisect an angle. You only bisect a straight line. Are you getting me? When you divide it into two equal parts. Okay, so a straight line that bisects a chord drawn from the center of the circle actually forms right angles with that chord. And so you, from here to here, now this is the point on the circumference. So from here to this point is actually your radius. And from here to here is also your what? Radius also. Now questions like this actually usually lead us to what? To using your Pythagoras theorem and your SOHCAHTOA. Moving to the third theorem. The third theorem will state that what? The angles in a semicircle are right angles, that is 90 degrees. How do we know this? If you have an angle that is formed like this, for example, how do we know that this is an angle in a semicircle? These two ends now, if you rule a line between them, do they pass through the center of the circle? If yes, then it is an angle in a semicircle, and it is automatically what? 90 degrees. No matter how many angles are in that particular circle, if there are angles in a semicircle, each of them. So if you have another one that is like this one now, are you seeing it? If you rule a line through like this, it does not go to the center. So this is not what? An angle in a semicircle. Are you getting me now? But for every angle that is in a semicircle is what? It is 90 degrees. Your center is there and you rule a line through 90 degrees. If you have another one like this, are you getting me now? is still also what? 90 degrees. So do take note. The fourth theorem states that angles in the same segment are equal. And so you have this and this. Now these two are equal and these two are also what? Equal. Do take note. The fifth theorem says that what? Opposite angles of a cyclic quadrilateral are supplementary. Now define certain terms there so you understand the statement better. Opposite angles, for example, in this place are what? A and C, B and D. So A is opposite to C and B is opposite to what? D. Those are opposite angles. They are opposite angles to each other. And in a cyclic quadrilateral is one whose vertices touches the circumference of a circle. These are the vertices. So if you have a shape like this, these are the vertices of your shape. Okay. And the word supplementary means that they add up to what? 180 degrees. So it means that what? A plus C is equals to what? 180 degrees. And also B plus D is equals to what? 180 degrees.